recording.
Okay, so I made up a question where we're going to calculate the number of molecules, moles, and the molecular mass. This is the basics as a review for your test. The question is as follows. Ammonium pyrophosphate. The following formula. Pyrophosphate is a -4 anion, so it's going to require 4 ammonium atoms, ammonium molecules. It says 12.34 grams of ammonium phosphate, from now on known as AP, is how many moles? So the first question is answered over here on this board. And I start off by dividing the molar mass, the number of grams by the molar mass. Notice how I use all the significant figures. I haven't rounded it off. And I get 5.014 moles. How did I set it up? I know that when I have grams and I'm divided by grams per mole, the grams will cancel, and because moles is in the denominator of the denominator, it becomes the numerator. So the answer will be in moles. So we have 5.014 times 10 to the minus 2 moles of ammonium phosphate. Now the second question, we're going to go back to the first board again. It says 5.05 times 10 to the minus 12 moles of AP, so it's a very small amount of ammonium phosphate. How many grams? We worked that out over here. 5.05 times 10 to the minus 12 moles times the molar mass. Now, the way I arrange this is so I can get grams. So I look at the units of the quantities involved. I want to get rid of moles, and I want to leave grams. So moles will cancel once I've multiplied them, and it'll be an answer in grams. Here's the answer in grams, 1.24 times 10 to the minus 9 grams. A more appropriate measure here would be to multiply by 1 billion nanograms per gram, so that your answer comes out as 1.24 nanograms. Here I show how I calculated the molar mass. Just simply add up all the masses of all the elements involved. Notice that there are 4 nitrogen atoms. That 4 outside of the bracket means there's 4 nitrogen atoms, and 4 times 4 hydrogen atoms, or 16 hydrogen atoms in one molecule of ammonium cyanate, pyrophosphate, sorry. Going on to C, the question for C is how much does 3.337 times 10 to the 17 molecules of ammonium pyrophosphate weigh? So here's the number of molecules. This is Avogadro's number. I haven't written out the number. It's embedded in the memory of my calculator to about 10 decimal places or 9 decimal places. So I say Avogadro's number, 6.02 times 10 to the 23 molecules per mole. Molecules will cancel, and we get an answer in moles because the denominator of the denominator becomes the numerator. Then we're asked to find out how many grams that is. So I know how many moles. I multiply by the molar mass, which is in units of grams per mole. Moles will cancel, and the final answer will be in grams. The correct number of significant figures is 4, because it said 12.34 at the beginning, so I can't report my answer to more than 4 significant figures. So the final answer is 1.364. That 36 rounds off to 4 times 10 to the minus 4 grams. Perhaps a more appropriate unit would be micrograms in this case, so I would multiply it by a million. 1 million micrograms per gram. Grams cancel, and the answer will be in micrograms, 136.4 micrograms. Question D asks, what is the mass of hydrogen in one molecule of ammonium pyrophosphate? We recall that ammonium pyrophosphate is 16 hydrogen atoms. So if you have one molecule of it, we have 16 hydrogen atoms. How much is that compared to a mole? Well, 16 atoms of hydrogen. I should have put hydrogen, I didn't write it down. Let's put H here. I will say Avogadro's number of atoms of hydrogen per mole of hydrogen. That will give us the fraction of a mole that we're dealing with. 16 divided 6.02 times 10 to the 23 times the mass of 1 mole of hydrogen atoms will tell us the mass of hydrogen, which is 2.67 times 10 to the minus 23. So it's a very small amount. And then we're only allowed 6 significant figures in this particular answer. So it ends up being 2.6779.6 times 10 to the 23 grams. And I left it in grams because there's no easy conversion there. Then we go to
Francis Adder, please come to the main office. Francis Adder, come to the main office.
Then we ask how many atoms are in 2.55 moles of ammonium pyrophosphate. We start off with the number of moles, 2.55 moles, times Avogadro's number of molecules per mole. Moles will cancel. And then we recall that there are 29 atoms per molecule. If you see ammonium pyrophosphate, you can count it up. There's 4 nitrogens plus 16 hydrogens. That's 20 atoms. 20 plus 2 phosphorus will give you 22, plus the 7 oxygens give you 29 atoms in one molecule of ammonium pyrophosphate. So, 29 atoms per molecule allows us to cancel molecules. So the final answer will be in the number of atoms. So 2.55 moles of ammonium pyrophosphate will contain 4.45 times 10 to the 25 atoms. And we're only allowed, I think, 3 significant figures in this one because the significant figures is determined by that question. Okay.